Have you noticed that sometimes your C code for the PSoC 3 can use up a lot of flash memory? There are reasons for that, not least of which is that the CPU in the PSoC 3, the 8051, is an 8-bit processor. But if you structure your C code to use some unique 8051 features, you can end up using a lot less flash and your code will execute faster too. And you don't have to write any 8051 assembler. You can do it all in C. Let's see how that's done. First, we need to look at some of the 8051's memory spaces. Most processors have a single linear address space that contains all of the flash, SRAM, and peripheral registers. The 8051 is different. It has 3 separate memory spaces. The first is the code space. It is 64 KB and in PSoC 3 contains the flash memory. The second space, called the external data space, is 16 megabytes and covers the PSoC 3 SRAM, all registers, and other features. The third space, called the internal data space, is actually part of the 8051 CPU core. It's only 256 bytes and contains 256 bytes of SRAM plus a set of special function registers. A lot happens in this space. General purpose registers, a bit addressable space, the program stack, general purpose SRAM, and multiple addressing modes. The 8051 is most efficient when it operates in this space, and a lot less efficient when it operates in the external space. Now let's see how the Kyle 8051 C compiler, included with PSoC Creator, handles these different spaces. Kyle defines memory models, typically using the terms large for the external space and small for the internal space. There are several other keywords that tell the compiler where, in these memory models, to place variables, structures, and arrays, and how to address them. The Kyle keywords are not portable to other C compilers like for PSoC 5, so PSoC Creator offers equivalent macros to make porting easier. So what happens if you ignore all this and simply write C code without any special keyword? This code, which does the classic Fibonacci sequence, will compile just fine, but the compiler will use the large memory model, the one that uses the external space, as a default. After we compile the program, the listing file shows us how much memory the compiled program will use. We can see that 43 bytes of external space, SRAM, are used to hold the variables and array, and the program will occupy 162 bytes of flash. No internal space resources are used. Now let's go back to the code and add the keyword data to place the local variables in the internal memory space. We'll leave the array in the external space because it might become too large for the internal space. After we recompile, the listing file shows us that 3 bytes were transferred to the internal space. But more important, the program will now occupy only 118 bytes of flash for a 27% reduction in code size. This is only one simple example of how you can make your C code run smaller and faster on the 8051. There are many others. For example, I mentioned earlier that the internal space has a bit addressable region within it. In bytes 20 to 2F, each bit is individually addressable, and there are a lot of very fast single-cycle 8051 assembler instructions to set, clear, toggle, and test these bits. You can even do and or operations on bits. Let's see how these features can be used in C code. This code manages some flag variables, meaning variables that are Boolean. Their values can only be 0 or not 0. These flags are usually of type char. When we compile, we see that the flags are stored as bytes in the external space, and 92 bytes of flash are required. We could move these variables to the internal space using the data keyword, as we saw in the previous example. But why allocate an entire byte to store the variable when only a single bit is needed? Since these variables are Boolean, we can instead redefine them using the keyword bit. After we recompile, we see that the flags are stored in the internal space as bits, and only 31 bytes of flash are required for a 66% reduction in code size. So, you've seen that with a few simple coding changes you can make your C code run a lot more efficiently on an 8051 processor. To see more coding techniques and overall code architectural solutions, take a look at Cypress Application Note 60630.